Hello students, this today I'm going to discuss the first problem based on the design of an arch dam. Okay, in this question we have to design an arch dam for a valley which is 20-meter at the base. Okay, and the height of this dam is 120 meter. Okay, and the top width of this valley is 100-meter at the top, which is at the 120-meter from the base. Okay, it means that suppose this is a valley. Okay, this is a valley, this is a valley, and this valley is say 20-meter at the base. Okay, and this is 100-meter at the height of 120-meter from the base. Okay, so this valley is like this valley is like this. Okay, this is 100-meter at the top. Okay, so now let us divide this. This is the vertical line dividing the valley. Okay, so say here this width will be 20-meter. Okay, this is 20-meter, and if suppose this is symmetrical, so we can say that this part is of 40-meter and this is 40. Okay, so this is the valley. Okay, now in this question we have to design a constant radius arch dam with the central angle of 150 degree, and also we will be designing a constant angle arch dam with the central angle of 133 degree 34 minutes. So in this we have to assume the allowable stress to be 400 tons per meter square and minimum thickness to be 2.5 meter. Okay, so now let us begin this problem. So here we have assumed the allowable stress to be 400 tons per meter square. Okay, and minimum thickness to be 2.5 meter, and also assume gamma W, that is unit weight of water, to be 1 ton per meter square. Okay, because this is in ton per meter square, so this should be 1 ton per meter cube. Okay, now in order to calculate the section, okay, we have to keep in mind this width of a valley because it is changing. Okay, this width is changing with the change in elevation. So suppose at a height of h, from the top, this is say x. Okay, this is say x, this will be also x. Okay, so from the base it will be 120 minus h. Okay, because the total height is 120, so this will be 120 minus h. Okay, now based on the similar triangle we can say that x over 40 will be equal to the total height, the ratio of the elevation, that is 120 minus h divided by 120. Okay, divided by 1. So here x can be written as 40 by 120. Okay, and 120 minus h. So on simplification this will be 120 minus h, and x will be equal to 1/3 of 120 minus 1/3 of h. Okay, so x will be 40 minus h by. So this will be x. Okay. So if suppose we want to calculate the total width or total span, you can say this, because this is the span of the arch dam. Okay. So at any height h meter from the base, if we want to calculate the span L, so this span L is equal to 20 plus twice of x. Okay. So this will be 20 plus 2 twice of 40 minus h by 3. Okay, so this will be equal to 20 plus 80 minus 2/3 of h. So L will be equal to 100 minus 2/3 of h. Okay. Remember this expression. Okay, since we are required to calculate the uh, constant radius algebra, so we are also required to determine the radius. Okay, so in order to determine the radius, let us say this is the arch. Okay, and this is the external radius. Say this is the center, suppose. So based on this, this is 2 theta. Okay, and 2 theta in this case is 150 degree. Okay, and this is the external radius RE, and this is the internal radius RI. The difference of this RE minus RI is the thickness of this arch dam. Okay, so let us say this is the arch. Okay, and yes, this one, this is the arch, and if this is the span L, okay, this line is perpendicular to this span, so this will bisect the angle, so this will be theta and this will be theta, and say this is external radius RE, so this is total span. Okay, so and this will divide this into L by 2. Okay, so L here will be equal to 2 RE sine theta. So you can say that RE is equal to L over 2 sine theta. Okay. Now, what should be the L? Okay, what should be the L? So L will be that span which is at the top. Okay. So at top L is say 100. Okay. 2 into sine, and this will be 150 by 2, because the central angle is 2 theta is 150, so theta will be 150 by 2. This is coming out to be 51.7638 meter. So on rounding off, we can have the radius to be of 52 meter. Okay, since this is constant radius arch dam, so we will take this radius throughout the height of the dam. Okay, so radius will be 52 meter. Okay, now another component that we are going to calculate, that will be the thickness. Okay, so in my previous lecture, okay, in my previous lecture I have discussed the thin cylinder theory, and on that thin cylinder theory I have discussed how to calculate the thickness. Okay, so there I derived the formula for the thickness to be gamma WH R over FC. Now since here we are considering the external radius, so say this radius is R. Okay. So we know the value of this gamma W. Okay. We know the value of this FC. Okay. We know the value of RE, that is 52 meter, and since this is constant radius arch dam, so throughout the height this will be 52 meter. Okay. Now the only variable here is the height of the dam. So this thickness will vary with the height. Okay, with the height. So how this will vary, we will see over here. Okay, now remember this expression. Okay, you have to remember this expression. Now let us simplify this further. Put the value of gamma W, that is 1, H is say H, RE 52 divided by FC is 400. Okay, FC is 400. So this is coming out to be, so thickness T is 0.13 of H. We have to remember this expression also. Okay. So now let us come over here. I have prepared a table over here. Okay. So you have to prepare this table. In this table, the first column represents the height H. This height H is from the top. Is from the top. This one. Okay. This one is from the top. So at the top, now since this is this height is total height of this arch dam is 120 meter, so I have uh, divided this into 12 parts of 10 meter each. So uh, let us say 110 and 120. Okay. Now next column is the span L. Okay, is the span L. How to calculate this span L? For that I have derived this expression. L is equal to 100 minus 2/3 of H. So let us write over here. This is equal to 100 minus 2/3 of. Okay. How to calculate RE? RE is constant, that is 52, and this will remain constant throughout the height of the dam. So we do not have to calculate it at every height. This will be constant 52. Okay, so copy all this in all the columns, in all the rows. Okay, this is the water pressure. This is the water pressure. So this is P will be equal to gamma W is 1, so this will be equal to H. Okay, this will be equal to H. How to calculate this thickness? For this, I have already calculated. I have already derived this expression. T is equal to 0.13 H. So let us now write over here. This T is equal to 0.13 of H. Okay, 0.13 of H. Now what is TR? Here TR represent the thickness in case of constant radius arch dam. So thickness for the constant radius arch dam that I will discuss. This is the internal radius, which is RE. RE is the external radius. This RE minus thickness over here. Okay, RE minus thickness. And theta will be the angle, central angle. Okay, since this is not the constant angle arch dam, so the angle may change. Okay, so now and how to calculate this? Since you know that over here R L is equal to 2 RE sine theta. Okay, so sine theta will be equal to L over 2RE, okay, and theta will be equal to sine inverse L over 2RE. So theta will be equal to sine inverse L by 2RE. So now let me write it over here, sine inverse L over 2R. Based on this expression, we have to calculate the span at each edge. So over here, since h is 0, so this will be equal to 100, okay, and at h equal to 10, so 100 minus 2/3 of 10 is 93.33. So put 93.33, okay. If it is 20, so this will be 86. So at the base, okay, which is 120 meter from the top, so the width is, the span is 20. Similarly, the radius, we have already calculated this radius to be 52 meter, and this is constant radius archdam, so the radius will be 52 meter. Now since this pressure is equal to h, so whatever will be the value of height here, this will be the value of pressure. Okay. Now next, the expression for calculating the thickness, we have already derived it over here. Okay, so this is 0.13 times h, so this is 0, this is 1.3, okay, at 20, this is calculated thickness at the top is coming out to be 0, but we cannot provide the thickness to be 0. We have to ensure a certain minimum thickness. So for that, in our problem, it is given that we have to assume the minimum thickness to be 2.5 meter. Okay, we have to assume this to be 2.5 meter. So if the thickness, calculated thickness, is less than 2.5 meter, so we have to ensure the minimum thickness over there. So here, since the thickness is 0, so the provided, this is the provided, so it should be 2.5. It is again 1.3 is less than 2.5, so we have to ensure the minimum thickness, and in all the rest of the rows, the thickness is greater than 2.5, so the same calculated thickness can be provided in all the elevations. Okay, so over here, since this is the external radius and this is the internal radius, and we have calculated the thickness over here, so we can calculate the internal radius. So internal radius, or you can say introdose, okay, this can also be known as introdose. So external is say 52 minus thickness, and this thickness is tr, okay, provided thickness. So 52 minus 2.5, okay, that is 49.5. okay, here also it is 49.5. this is the radius, okay. Let us now calculate the angle. Okay, so let us say this is 2 theta, so it is twice of sine inverse L by 2. Okay, in that case we can calculate the whole central angle. Okay, earlier it was half, so let us say it is the central angle. So this is twice of sine inverse L by 2 RE. So L is here 100. Okay, RE is here 52. So now let us prepare a general formula for 2 theta. 2 theta is equal to 2 into sine inverse L. L is variable over here and it is 2 by 52. Okay, so only you have to put the values of L. Okay, so this is how uh, we can design a constant radius arch dam based on the thin cylinder theory. I hope you understood this illustrative example. Okay, if you have any problem in this related to this theory and related to this design of arch dam, of constant radius arch dam, so you can ask your question. Okay, and you can very well post your questions in the comment. Okay, and I'll be happy to answer. Okay, thank you, that's all for now.